Alright, let's go over solving compound inequalities. So a compound inequality just means that we have two inequalities to be aware of when we find our solution. So 2x plus 5 is less than 7 and 3x plus 8 is greater than or equal to negative 21. So there are two constraints for our value of x. So let's solve this. Just this one by itself, minus 5, minus 5. And now we have 2x is less than 2. So now divide by 2 to solve for x, divide by 2. We find that x is less than 1. Okay, but it's not any number less than 1 because it also has to satisfy this inequality. So now let's solve here. Minus 8, minus 8. 3x is greater than or equal to negative 29. Alright, so now divide by 3. Divide by 3, and x is greater than or equal to negative 29 over 3, which we could write as a improper or mixed number. It's currently improper. 3 goes into 29 9 times to be 27, so there are 2/3. So now if we graph this, we have negative 9 and 2/3 and positive 1. So x is less than 1, so it starts at 1 and it goes everything below it. Okay, but then x also has to be greater than or equal to negative 9 and 2/3. So this is a solid circle. So let's shade this in. And it's everything greater than it also, so it goes this way. But you see that they overlap. So we're constrained. It's everything from negative 9 and 2/3 up to 1. So this is our solution. And we can write it like this. So x is less than 1, but it's also greater than or equal to negative 9 and 2/3. So if it has and, it's going to be between these two values, and we can write it like this. Another way that it can be written is as one inequality. So we have 2 is less than or equal to 3x plus 8 is less than 14. So this is also an and, where x is going to be bound by two values. So we could solve this whole thing at once. So minus 8 here. Then we have to minus 8 from this side of the inequality and also from this side. And remember, we're trying to isolate x. So here, that goes away. 2 minus 8 is negative 6. So negative 6 is less than or equal to 3x. And then 14 minus 8 in this case is positive 6. So now solving for x, divide by 3, divide by 3, divide by 3. Negative 6 divided by 3 is negative 2. We divided by positive, so this stays the same way. And 6 divided by 3 is 2, so we have a solution like such. Negative 2, 2. X is everything between it, so it can equal this because of this sign here. It cannot equal this one, so that's open, and it's everything between. And of course, these aren't going to come out to be the same values, but opposite, like negative 2 and 2. This could have been a 5 or something like that. So I'll just quickly do a similar example. So let's see, what can I make this? Let's make this 20. So now same thing, minus 8, minus 8, minus 8. Again, negative 6, 3x. This time we have 12. Now we divide by 3. We get negative 2, x, and 4. So this time we have negative 2 to 4. Again, this one's solid, this one's open, based on these signs, and that's our solution. In this compound inequality, we have an or. So you see it's going to be a little bit different. Still, we're going to solve each of these individually. So minus 5, minus 5. 3x is less than negative 4. Divide by 3, divide by 3. X is less than negative 4 over 3, or negative 1 and 1/3. Or 2x minus 8 is greater than or equal to 12. So here let's solve, add 8 to both sides. 2x is greater than or equal to 20. Now solve for x, divide by 2. divide by 2, x is greater than or equal to 10. So we have our OR here still. So now when we graph this, we have negative 1 and 1/3. We have 10. So x is less than negative 1 and 1/3, so it's an open circle, and it goes to the left because it's less than it. Or x is greater than or equal to 10. So here it's solid, it's everything to the right. So you see, these do not overlap. So we can add our arrows, and it's OR because it's only going to satisfy one or the other. So the value that satisfies this inequality will not satisfy this one. So it's just one or the other, not AND where it satisfies both.